Now in this question, we have two charges A and B, each of charge Q, and are separated by a distance D between them. There is another charge C which is at a distance D by 2 from B as well as A. Now according to the A part of the question, that is, if the charge C is displaced by a distance x in the direction perpendicular to AB, then the electric force that is experienced by it can be easily calculated by the vector addition. The one thing to be noticed that when the charge C is displaced by distance x, then the force on C due to A will be equal to force on C due to B. Now let us say the line of force between A and C is this FCA, and the line of force between C and B is this is F on C due to B. Now on resolving the components in the two direction, let this angle be theta. Now by equal and opposite angles, this angle is again theta. So it can be easily calculated that tan theta is given by D by 2 divided by x. Now net force acting on C due to A and B is F net, that is equals to 2 times of force on C due to A into cos of theta. So 2 times of K into Q divided by distance between the charge C and B, that can be given by D by 2 whole square plus x square. Because this distance is D by 2, this is my x, so by Pythagoras theorem I can easily calculate the hypotenuse of the right angle triangle, that is given by D by 2 whole square plus x square to the power 1 by 2. That is my distance r. Now as in the denominator there is r square, so the 1 by 2 into 2 will give me 1, and so the denominator is D by 2 whole square plus x square into cos theta. Cos theta is again base upon hypotenuse. Here my base is x divided by hypotenuse, that is nothing but r, so D by 2 whole square plus x square to the power 1 by 2. So I'm solving, I get 2k capital Q small q into x whole divided by D by 2 whole square plus x square to the power 3 by 2. This is my answer. Now if we assume that x is very less than D, then D by 2 whole square plus x square to the power 3 by 2 can be assumed to be D by 2 to the power square 3 by 2. What we did over here is that as x is very less than D, so x can be neglected in comparison to D by 2. So F net will turn into 2k capital Q small q into x divided by D by 2 to the power 3, and clearly that F net is directly proportional to x. In C part, we had to calculate the condition that if it is released after such a small displacement, then what will be the time period. Now we calculated in the second part that F net is given to me by 2 times of K capital Q small q into small x whole divided by d by 2 whole cube. Now in case of SHM, the force we know is given by mass into acceleration. Now let's say a particle is performing an SHM, then the displacement can be given by a sin omega t, as we all know, and differentiating this equation twice we'll get velocity as a omega cos omega t and acceleration as minus a omega square sin omega t. So in case a particle is performing a simple harmonic motion, then the acceleration can be easily given by minus of omega square x sin omega t. Now in this case we have the maximum displacement, so the net force is given by 2 times of K capital Q into small small x divided by d by 2 whole cube. That will be equal to mass into acceleration, and the acceleration as we calculated will be omega square into x. Now solving this equation for omega, first of all we get x is cancelled from both the sides. We have 16 K capital Q into small q divided by d cube is equals to mass. Now omega, as we know, is given by 2 pi by capital T, so it will be 4 pi square divided by t square. So t can be easily calculated as m into 4 pi square into d cube divided by 16 K capital Q into small q into 1 by 2. That is my answer.